Hello guys and welcome back to my channel KK Tutorials. So today we will be solving some more problems based on integration. So the first problem states that find in is equal to integral of log x to the power of n dx, and hence find in plus n into in minus 1. So let's start solving the problem. So to solve this problem we need to use the UV rule of integration, which states that integral of f of x g of x is equal to f of x into integral of g of x minus integral of f dash of x into integral of g of x. Okay, so here the first functions are logarithmic function and there's an algebraic function which we need to assume into 1. So according to the Eilert rule, logarithmic function comes before the algebraic function, so the first preference of f of x should be given to the logarithmic function. So let me take the logarithmic function first. Log of x to the power of n into dx minus log of x to the power of n minus 1 into n by x into d of x. So now simplifying this further, I will get x log of x to the power of n minus log of x to the power of n minus 1 into n, as integration of dx is x and x gets cancelled over there. So x log of x to the power of n minus n log of x to the power of n minus 1. So the left hand side is actually in, which I have not written till now. So now this thing over here is actually n into in minus 1 over here. Sorry for this, I'll just use the eraser right now. And this is just in minus 1 over here. So x log of x to the power of n, in is equal to x log x to the power of n minus n into n minus 1. So let me take the second term that side. So in is in plus n into in minus 1 is equal to n into x log of x to the power of n. So this will be your answer. So now let's move on to the next question, which states that integral of 1 plus tan x dx by e to the power of minus x cos x is equal to e to the power of tan x plus c, e to the power of x secant x plus c, e to the power of minus x secant x plus c, or e to the power of minus x tan x plus c. So now let's solve the problem. So let me try bringing e to the power of minus x to the numerator. So e to the power of x 1 plus tan x by cos x. So now simplifying it further, I will get secant x plus tan x secant x. So as you can see, it is of the form e to the integral of e to the power of x f of x plus f dash of x, which is equal to e to the power of x f of x, as secant x derivative is tan x secant x. So this is f of x and this is f dash of x, so which will be equal to e to the power of secant x plus c. So B is your answer. So your next question asks you to find sin x cos x by root of 1 minus sine to the power of 4 dx. So we need to find this value, right? So let me make the substitution t is equal to, or let me just use a different color pencil, or it looks pretty monotonous and boring. The same color looks pretty monotonous and boring always. So I'm a person who believes that things should be made colorful. So let me use t is equal to sine square x as a substitution. So now let me differentiate t over here. dt is equal to 2 sine x cos x, hence dt by 2 is sin x cos x. So let me put this value over here. So I will get dt by 2 root of 1 minus t square. So simplifying further, I will get dt by root of 1 minus t square. So now I need to use the result. Let me just write the result in a different color. Okay, so dx by root of a square minus x square is equal to sine inverse of x by a, so plus c. So this is the result that I need to use right now. So using this result, I will get 1 by 2 sine inverse x plus c as your answer. So sorry, this is not x over here, so that is t over there. I just made a mistake there. So that's t over here, and let me put sine square x in place of t over here. So it will become 1 by 2 sine inverse of sine square x plus c. So this will be your answer. So now let's move on to the next question, which states the value of integral of x square plus 1 by x square minus 1 dx is. So to solve this problem, we need to split this numerator into x square minus 1 plus 2. So let's try doing that right now. So integral of x square minus 1 plus 2 by x square minus 1. So this can be simplified further as 1 by 2 x square minus 1 dx. So now let me split this, dx plus 2 by 1 by x square minus 1 dx, so which will give me x plus 2 into x square minus 1 dx. And we know the result. Let me just write the result in a different color right now. So integral of 1 by x square minus a square is 1 by 2a log of x minus a by x plus a. So we know this result, so let me apply this result over here. So change the color of right now. So equal to x plus 2 into 1 by 2 log of x minus 1 by x plus 1 plus c. So these two get cancelled over here, so I'm remaining with x plus log of x minus 1 by x plus 1 plus c. So this will be your answer.